So, a couple of, we're in 2-4, we'll have variables on both sides. When you have variables on both sides, it's possible that you end up with something called an identity. Here's what an identity is. It's an equation that is true for every possible value of the variable. So find 2-4. Very beginning of it. And we're defining an identity. Identities are going to show up today. You may not know it's an identity right off the bat, but once you simplify it, maybe distribute or combine like terms, you'll notice that you have an identity. So what's an identity? An identity is an equation that is true for every possible value of the variable. So we learned that some equations, anything you plug in for actually works. Anything you plug in, it wouldn't matter. If you think about identity like this, if you look in the mirror, who do you see? Yourself, yeah. So that's kind of what's happening. It's like the mirror is the equal sign, so you realize that as you're going through and solving it, that the left side and the right side are exactly the same. You may not notice that on the first step because it needs to be simplified. But as you're going through, you'll go, and you can stop as soon as you see that, okay? You see the left and right side exactly the same, you just stop and you write down identity or all real numbers, and that's going to show us today. So we're now at a point where once we can solve an equation with variables on both sides, we're about ready for a skill test. So we're going to have a little quiz on Wednesday that will cover these first 4 sections of equation solving. And we may even start the first of our skills on this. And you'll have 4 tries, and you keep your best 3. So. But we're going to be starting on that as well. It's scored on a rubric. I think it's out of 10. I'll have to get back with you on that. I'm sure what no, you're really good. I'll bet you get it. Bet you get it. So, concept summary. This is a summary of what we've done so far with solving equations, and that is deal with parentheses first. So if you see parentheses in your equation, what do we mean by deal with it? Yeah, do the distributive property. Do it. Get rid of them. So deal with parentheses, that's step 1. Combine like terms on each side of the equation. The reason I added this phrase on each side of the equation is because I don't want you to confuse this with doing inverse operations. So it's separately. Combine like terms on the left side, combine like terms on the right side. You're not adding or subtracting from each side yet. Step 3 is gather all the variables on one side and constants on the other. So that means, I'm going to demonstrate that today. If you have variables on both sides, you want to get the variable onto one side. And then the other side will be just constants. Gather all variables on one side, constants on the other. And step 4 is get the variable by itself. That's when you start doing inverse operations. So get variable by itself, solve. And check. You can put just check. Check would be good. Check solution in the original equation. You don't want to check it at any other point because you might have made a mistake at one of those other points. But in the very beginning equation, plug your number in there. And I've said, I mean, some of them, just a mental check. Some of them we should probably plug it in. On your skill test, would be a good idea to do. Maybe ask to do that and show your work. So check. So that's the 5-step process for solving an equation. That's our goal, is that you can solve a multi-step equation with parentheses in it, variables on both sides. It kind of looks like the last problem in that diagnostic we did a second right here. So that's the goal for this whole unit. So check. All right, so here's an equation. It has variables on both sides. There's different things you could do here. I like to deal with the variable first. Okay. There's no parentheses. There's no like terms on separate sides here. 2x and 14 are not like terms. You can't combine them. 5x and 2 are not like terms. You can't combine them. So I'm going to deal with the x here. I could subtract 5x from each side, but that would give me a negative x on the right side. So I would prefer just subtract 2x from each side. And I'm going to write minus 2x right underneath its like term on each side of the equation. So I have 3x plus 2 equals 14. And now it's just a two-stepper that we've done before. So once you get that variable on one side, it doesn't have to be the left side. I actually will try and make it so that I add or subtract appropriately to get a positive number in front of the x.
So you can go either side, but as long as there's no negative?
That's what I do, yeah. Either side as long as there's no negative. Yeah.
We'll get the same.
You will. I mean, if I went over here and took the same equation and I subtracted 5x from each side, that would work as well. But now I have a negative 3x in there. And I just need to make sure I don't forget to write the sign down as I go through. I've noticed students do that sometimes, just kind of miss the negative sign. Sometimes the teachers do it. I do. But that would be the only reason why. But either way will work. I can solve this. I'll show you what I mean. Then it's just what we've done before. So let's finish it out here. Subtract 2, 3x equals 12. Divide by 3, x equals 4. And over here, if I did the same thing, I would subtract 14. So what happens is I end up with a negative 12 equals a negative 3x. Well, when I divide by negative 3, I still get x equals a positive 4. So it works fine. It works just fine. So why don't you try the next one here? I'm just going to give you like 1 minute to try it. And then I'll put the solution up. Okay, so this one ends up being k equals negative 4. And this is asking the question that I already answered up here. So could you have solved the above problem by subtracting 7k instead of 4k first? Sure, yes, you could have. Yes, you just leave it at yes, but I demonstrate up here what would happen. You get the same answer, you just have to deal with negatives. So that's what that question's all about. The truth of the matter is you could even start with the constants and start subtracting or adding those, but I usually just take care of the variable first. That's my recommendation. All right, using an equation with variables on both sides. So this one is forcing us to write an equation. What we'll have is one expression with an x in it on the left and one expression with an x on the right. The first expression is going to come from this first sentence here. It takes 1.5 hours to make a web page. The question is how many, well, let's read the rest. With new software, she could complete a page in 1.25 hours, but it takes 8 hours to learn the software. So she's got to go spend 8 hours to learn the software, but then it's going to speed up the process by 15 minutes or a quarter of an hour. Okay, so it says how many pages would she have to make in order to save time using the new software. So after going through the training, how many hours after that is it going to take to make it worthwhile. So the x equal number of pages So we've got 1.5x equals 1.25x plus the 8 hours that are killed in the training, or, well, I shouldn't say killed, that's kind of negative, but the 8 hours of professional development to improve her skill and her ability to complete some web pages. So then we have to just solve that for x. And it'll tell us how many hours. So it's already losing 8 hours in the training, right? So it's going to have to be 8 hours plus something. So, but let's go ahead and solve this. If you subtract 1.25x from each side, we get 0.25x equals 8. So how many times is 0.25, or how many times is a quarter going to $8, right? Yeah. 32 times, yeah. So divide by 0.25, so I think we can do this without a calculator. So x equals 32, and the 32 is representing pages you would have to make. And then it's kind of a break-even deal in terms of time. So here it says, and now you try. Let's do this together. An office manager spent $650 on a new copier that will reduce the monthly electric bill from $112 to $88. So in how many months will the new copier pay for itself? So x equals number of months. Kind of see how this lines up with the others. So the electric bill each month without this copier is $112. That's going to kind of be like the web designer working without the training, okay? So it's 112x equals, we're going to set them equal to each other. Now the monthly bill will go down to $88, but you got to spend $650 on the new copier. So it's 88x plus $650, and that would be the cost per month plus the $650 for the new copier. So it's pretty similar setup to that one. That's what we're looking for. You're going to have variables on each side, two different expressions. One of the expressions adding some fixed value on there. Subtract 88 from each side. Let's see. 24x equals 650, and then divide. We can do the long division of 24 into 650. You're using our calculator. What do you get?
27.08.
27.08. So the question is, in how many months will the new copier pay for itself? It's going to be more than 27 months, but we add in months here, or you could say just over 27 months, or you could say by the 28th month, either one. After a little over 27 months. It'll pay for itself. Alright, so you'll have just some on the classwork and homework that you have to set up a problem first. Expect there to be a letter, a variable on each side. Then you're set. Alright. This one, we add in parentheses. So remember, we got to do parentheses first. Parentheses first. So if I distribute the 2, I get 10x minus 2. If I distribute the 3, it's 3x plus 33. And now this looks like problem 1. So what would I suggest you do on this one? Yeah, I would say, yeah, that's what I would do. Your choice, you get to choose your own adventure on these equations as long as you don't break the rules. So I would try and keep the number in front of x positive. So 7x minus 2 equals 33, and now it's just add 2 and then divide by 7. So x equals 5. We could do a mental check here. Plugging in 5 up here on the right side, 5 plus 11 is 16. 16 times 3 is 48. Plugging in 5 here, 5 times 5 is 25. 25 minus 1 is 24. 24 times 2 is also 48. So that one works. Let's just choose one of the now you tries to do. Why don't we do, let's just do this first one here. They're pretty similar. Go ahead and try this one right here. And then I'll work it out. I'll give you a minute to do that, and I'll give you the solution. It should end up with y equals negative 5. Y equals negative 5. All right, identities and no solutions. So there are, you don't always have a solution to an equation. Let me give you an example of that. Here we would get rid of parentheses first by distributing. So I have 10x plus 12 on the left. Can't do anything with that. But then after I distribute, I notice I have 10x plus 12 on the other side. So we got our mirror image happening here, right? The left side and the right side are exactly equal. So when that happens, it's called an identity. So you could write down the word identity. And we have all real numbers. That's the solution. It equals all real numbers. So if it asks what's the solution, you'd say any real number, all real numbers. If it asks you what type of equation it is, you'd say identity. I've seen them do both in either the book or the classwork. So. Yeah.
Isn't there a symbol for all real numbers? Like it's an R with
two? It's called the chalkboard script R. It's like a bold, but they just do an extra line on the R. Yep. If you want to, you can use that. So if you'd like to use this, you can. It's just, and it's a capital R with an extra, a vertical line next to the left-hand side of it. Just like that. That'll do for the R. All right. So this one, let's see what happens here. It's kind of hidden. 9m minus 4, can't do anything with that. This one would be negative 3m. You combine these two. Plus 12m is 9m plus 5. We got a problem here. We've got almost an identity, but look what happens when I subtract 9m from each side. What's that? You could do the constants. I'm going to deal with the variables first, and this is part of the reason why I deal with variables first, is I get this statement, negative 4 equals 5. That's not a true statement, right? Negative 4 is not equivalent to 5. When you get a statement that's not true, so the variables cancel out completely, and you get this equation that's not actually an equation. This is the category no real solution. So just label that no real solution. All right, I'd like you to try the next two. See which categories they fall into. Category or categories. So yeah, check those. The first one should have been all reals. They match perfectly after you distribute. And then the second one was no solution. Once you distribute that negative sign, right here you get negative 3 plus 2x. I'll show you what it looks like here. So because the 2x's would cancel out, see right here, there's no way these are going to be equivalent. The 2x's would cancel out, you'd have 7 equals negative 3, which is nonsense. So that's no solution.